In the last part of the previous video, we had discussed there is alpha tetramers that occurs in case of beta thalassemia. I had to correct myself. So in beta thalassemia, what happens is that there are no beta chains. When there are no beta chains, when there are no beta chains, alpha forms a dimer alpha alpha and gamma gamma kind of a hemoglobin that is called as hemoglobin F. And now what happens is it leads to an important problem that the oxygen starts binding to hemoglobin F and is not available for the tissue, leading to tissue hypoxia. And when kidney is not receiving enough oxygen, or rest of the tissue also not receiving enough oxygen, it leads to increased production of erythropoietin from the kidney. That leads to increased production of RBC from the bone marrow. It's called erythroid hyperplasia. Increased RBC production, and these RBCs are going to have the HbF, and these cells do not survive very long. They also undergo cell death. Now, what happens when there is increased erythroid hyperplasia in the long bones? The long bone says the brain, why is it only suffering? Why not the other bones? So then erythropoiesis from all other bone marrow also starts occurring. In the skull, you get a crew cut appearance. It'll be like nails are stuck on the skull surface. And it also stimulates the other organs like the spleen and liver to start producing RBCs. Now, when all this is happening, the demand for iron is increasing. So there'll be increased absorption of iron from the gut. And at the same time, because they are transfusion dependent, I told that beta thalassemia major is also called transfusion dependent anemia. So because they're transfusion dependent, the iron in the body is increasing more and more. So it leads to hemochromatosis, and the treatment for it is using iron chelators like desferrioxamine, which will bind to the iron and excrete it in the urine. And this is the crew cut appearance. You can see that the skull is present here, and there are multiple lines originating from the skull. Right? It's because the skull is so actively producing the RBCs. And this is the classical face of a thalassemic patient. As such, I've seen around 6 to 7 patients may not have all the features. This is characteristically called as chipmunk faces in a severely affected child. Otherwise, you will see some features. So apart from that, this is beta thalassemia major, which I've already told you. And now I'll be telling you the details